We have two sections that talk about more properties and give us more practice with these properties on logarithms. And there's some really cool places for where these properties come from. But I think it's just going to take too much time and not get enough value. So if you're curious about where these come from, you can ask me, or you can Google like, where do log properties come from or something like that and get some cool explanations. But I don't want to fill a lot of our time with where these come from, but it is cool. The book also has some explanations that are pretty good. Okay. And yeah, we do have a textbook. If you remember, you can check it on the syllabus or the main page of Canvas. Anyway, so we have the exponent property, is this one, which basically says that if we have an exponent inside of that logarithm, that exponent comes down in front of the logarithm. Which is kind of crazy, but it works. It's true. And then also, if we have a logarithm, we can change the base to any base we want. If I have a logarithm with some base, the log of a, we can write that with any base as long as we write the new base on top, change the base to whatever we want. So it's still log of a, but we change the base to any c that we want. That's positive. As long as we divide by the logarithm of the base with that same c. We'll get some practice with these, so don't worry too much about them so far. So this one says rewrite the following using the exponent property for logs. So we need to use this property. Not obvious how, because there's no r in front, and I don't see an exponent either. But my claim is that we actually do have this thing on the left. Why? Because we can rewrite 25 with an exponent. That's 5 squared. And now it looks like this exponent property. Exponent property says we can take our exponent inside of a logarithm and bring it out in front. So this is going to be 2 times log base 3 of 5. You might say, I don't believe you, Jason. I'm doubting you. No way. Log base 3 of 25? What is that? Log base 3 of 25? About 2.93. And you said that's the same as 2 times log base 3 of 5? Ah, look at there. A little mathemagic for you. We can see that it is the same number. Oh. We can talk more about where that comes from later. Let's do that backwards with letter B. So now we have a number outside of the logarithm. Sometimes we want to put it in. Like really, these properties are just working our muscles. We're not accomplishing anything. This is not necessarily nicer than this. We're just working out. We're bench pressing. We're putting a weight up, and then we're bringing it back down, putting it up, just so we can build those muscles. That's what we're doing here. We're building math muscles. Sometimes we'll want to put the exponent up. Sometimes we'll want to take it down. So let's get practice doing both. So this next one, remember natural log is log base e, but we don't really have to worry about that. This says that, let's just go backwards. This is what we have here. Some number times a logarithm. We can bring that into the exponent. That's going to be the natural log of x to the 4th. That's true for any x. And I can, show that a different way on Desmos. We have 4 times the natural log of any number. Call it a. And is that going to be the same as the natural log of any number raised to the 4th power? And look, any number I choose for a, these things are identical. Any one we choose. We don't want negative numbers, though. Negatives are going to do weird things for us. There we go. That's how we do it. Whoa, that was not circling. That was erasing. Do one more. Do we need to write this? It's the natural log of x to some exponent. Remember your properties of exponents from way back when, whenever that was. That if we have a negative exponent, that means reciprocal. If I have something like a over b to the negative 1, it's going to be b over a. Anytime we have a negative exponent, that means reciprocal. Sometimes this popped up as if we had, you know, like x to the negative 2 over y to the negative 3 times z. The x would go into the denominator. The y would go to the numerator. Hopefully you've seen this before. If not, here's a little crash course. Negative exponents mean flip it. So this is the same thing as x to the negative second power. And now we can use the property. That little exponent comes out in front. We get negative 2 times the natural log of x. So on Desmos, looking at example 7, on Desmos, we can evaluate this log no problem. But on a handheld calculator, there's only a common log and a natural log. On a handheld calculator, if we need to evaluate this, we have to use the change of base formula. Remember that change of base formula said that we can evaluate a logarithm by rewriting it as any other logarithm, as long as we divide by the logarithm of the original base. So let's copy that formula down and do this problem. Formula says log base b of any number is we get to choose a new base of that thing. But if we do change the base, we have to divide by the logarithm of the old base. So if we want to write this, we can rewrite this as a common log or a natural log if we want to use our handheld calculator. Your choice. Let's change it to, well, common log makes a lot of sense because we already have a 10. So we can change it to the common log of 10. Change the base to the common log, no problem. But if we do that, we have to divide by the same logarithm, but now of the original base. That b is now on the inside if you look over here on the formula. That's the change of base formula. Lets us rewrite logarithms with any base. And we know the common log of 10 is 1. Why do we know that? Because this is 10 to the first power. So the common log and the exponential function cancel each other out. We're just left with that hidden exponent of 1. Now we could use our calculator to evaluate this. 1 over the common log of 2. Which is about 3.3219. And just like before, this number should kind of make sense because 2 cubed would be 8, 2 to the 4th would be 16. So the exponent that makes this true should be between 2 and 3, like we did in a previous video. That's one of the ways that you can use a change of base formula. We'll use it a little bit. Have a good one.